All right, today, section 8.6, area of a sector, a segment, and an annulus. On this slide, we define a sector, a segment, and an annulus. So we have a diagram to go with each definition. A sector of a circle is the region between two radii and an arc of the circle. You can see in the diagram, we have one radius, two radii, and an arc on the circle. Everything in between those is the sector. A segment of a circle is the region between a chord and an arc of the circle. Looking at the diagram, we have a chord and an arc. Everything between that is a segment. And lastly, we have the annulus. An annulus is the region between two concentric circles. You'll remember concentric circles are circles that have the same center, where one circle lies inside of the other circle. So obviously we have the big circle here, and we have the smaller circle that lies inside of the big circle. They both share the same center, and the annulus is the area in between those circles. Okay, to find the area of a sector. A sector is a portion or a slice of the circle, right? So we are going to take the portion of the circle that it is, which is represented by A over 360, where A is the arc measure, and then multiply it by the area of the entire circle. So we end up with the formula for area of a sector, A over 360 times pi r squared. Next, we take a look at the area of a segment. So the area of a segment is actually a portion of the area of a sector. Right? If you look at the diagram up here, this would all be a sector. Well, we can find the area of that sector. Then we would take out the area of this triangle, and we would be left with the area of the segment. And that's what's being shown to you sort of piece by piece here. The area of the sector minus the area of that triangle will leave us with the area of the segment. So when we piece together those different formulas, we have the area of the sector minus the area of a triangle, and that obviously will equal the area of the segment. And the area of an annulus. So in this case, we're going to take the area of the big circle. We're going to subtract out the area of the little circle, and that will leave us with the area of the annulus. So we simply apply the area formula of a circle twice, noting, obviously, that the radius in the big circle will be bigger than the radius in the small circle, thus the difference between the capital R and the lowercase r. And when you subtract the two, you'll be left with the area of the annulus.